Hey guys, today we're going to talk about scale factor and similar figures. Now, similar figures can be defined as figures that have this exact same shape. Okay? They have corresponding angles, which will have the same measures, and their side lengths will be proportional. So, for example, a rectangle and a triangle are not going to be similar figures because they do not have the same number of angles. Therefore, their angle measures will be different and their side lengths will be different. So you could have two hexagons that are similar or two triangles that are similar, but they have to be the same exact shape. And then scale factor is the ratio of the size of a model to the size of an actual object. Scale factor deals with like maps or blueprints or models, and we'll look at some examples of those in a few minutes. So when we're looking at similar figures, okay, here we have two parallelograms. And we have a width of 4 and a height of 10, and a smaller similar figure has a width of 2 and a height of x, we don't know. And we have these little hash marks here to signify that this line here is congruent to that line, and this line here is congruent to that line. So what we're going to do is we are going to set up a proportion for these to figure out our missing side length. And when we do this, we need to be consistent, and I'm going to stress consistency throughout this video. So we are going to start off with our long side here. We're going to put that on top, and we're going to put our short side on the bottom. Okay, and this is a proportion for our larger figure. Okay. And then on this side, we're going to do the same thing. So we're going to put our longer side over here, but we don't know what that is, so we're just going to put x over there. And we're going to put our short side on the bottom here, okay? So then we're going to cross multiply. We're going to cross multiply 10 times 2 and 4 times x. 10 times 2 is 20. 4 times x is 4x. Then we're going to divide both sides by 4 to get that x by itself, and we're going to end up with x being 5. So our missing side length is 5 there. Now that's okay for our shapes that are positioned the same way. What if they're positioned differently? Well, here we still need to find the sides that are similar. Okay, so we have our long side here. This is going vertically. And we have our long side here, which is going horizontally. They're still similar, as indicated by these hash marks here, okay, for these two rectangles. So again, we're going to start off with our long side here on top for this larger figure. So 14 over our unknown short side here, which is going to be x, and that is going to be equal to our long side of 8 over our short side of 3 on the smaller figure. Okay, we're going to cross multiply again. 14 times 3 and 8 times x. We will get 42 is equal to 8x. Divide both sides by 8 to get x by itself, and in this case x is 5.25. Another similar figure question you will see quite often is dealing with the height of something and its shadow that it casts, and then the height of another object, and then the shadow that that casts. In this case, I have a tree and a man, and they are both casting shadows. And you can see from my excellent artwork, I gave up the idea of drawing pictures for Marvel Comics a long time ago. But I have an 18-foot tree, and that casts a 52-foot shadow. And then I have a 6-foot man that casts a shadow of indeterminate length, so that's what we need to figure out. So here again, we need to be consistent. I put the actual height of the tree, which is 18 feet, over its shadow, which is 52. I then put the actual height of the man, over his shadow, which we don't know. Okay, so I was consistent. Okay, I put the actual height over the shadow, actual height over the shadow. Okay, so from here we're going to cross multiply. 18 times x is 18x, and then 52 times 6 is 312. So we take 18 and divide both sides by 18. So we'll be left with x on this side, and when we divide 312 by 18, we get 17.3 repeating feet. So his shadow he's casting is 17.3 repeating feet. And then we get questions that deal with scale factor. And as I said, scale factor deals with maps and with models. So if any of you do any modeling, like building model cars, they'll have a ratio of on the boxes of the cars that say like 1 to 6, and that would be like 1 millimeter is equal to 6 inches of the real car. So 1 millimeter on the model is equal to 6 millimeters of the real car. So in this case we have a map, and the map has a scale of 2 inches, which is equal to 7 miles. If the actual distance in miles between Revin and Malton is 33 miles, how far apart would those two towns be on the map? Okay, so again, when we're doing this, we need to be consistent. Okay, so if I'm putting the inches on the scale, which is 2 inches is 7 miles, I need to do the same thing for the other ratio. We're looking for inches, but we know that the distance between those two towns is 33 miles. So again, we're going to do inches over miles here, inches over miles here, being consistent. We will cross multiply. 2 times 33 and 7 times x, we'll get 7x is equal to 66. We will divide by 7 on both sides and end up getting 9.43 inches. And that is how far apart those two towns would be on the map. Okay, folks, we will be practicing this in class, and I will see you there. Oos!